All right, everybody, welcome back. Today we're going to be taking a look at the study guide for Unit 7. So I'm going to be working through each of these problems and being able to hopefully show you the process. Let's start with number 1 in 7.1. We're asked to put everything in standard form, and you should always try to start by putting it in standard form. So what we can do is, to put it in standard form, let's find the degrees of all of these terms. Well, our first term, we just have to count up all the variables in this term. F squared is f times f, so that's 2f's. That's why it's f squared. This is degree 2. What about the next term? Well, in this, there's only one f, so it's degree 1. In the last term, f to the 4th means there are 4 f's being multiplied together. It's degree 4. So in standard form, we are putting these in order from the highest degree to the lowest. Since f to the 4th is the highest degree term, we put that first. Since f squared is the next highest, we put plus f squared, since again this is a positive f squared. And since we have a negative 2f, we put minus 2f at the end. That's standard form. The reason we do this is because it's easier to find the degree and leading coefficient. The degree of a polynomial is just the highest degree monomial. So 2, 1, 4 is the highest degree monomial. So the whole polynomial is degree 4. As for the leading coefficient, that's going to be the number before your highest degree term. But we don't really see a number in front of f to the 4th. The number that's secretly in front of f to the 4th is 1. And any time you don't see a number in front of there, your leading coefficient is 1. So for problem 2, it's very similar. We take a look at the degrees. This has a degree of 1. This has a degree of 2. And if this doesn't have any variables in it, we say it's degree 0. So when we put it in standard form, the degree 2 term goes first, because it's the highest, then the degree 1, then the degree 0. Next up, we take a look at the degree of the polynomial. It matches the highest degree term. Since 2 is our highest degree term, we say the degree of the whole polynomial is 2. Here, the leading coefficient, the first number before our leading term, is 3. It's the number multiplying x squared. Down below, we're asked to add polynomials and subtract. Remember that this just means combine like terms. So for adding polynomials, we are adding together a negative 3a and a 7a. What's negative 3 plus 7? It's going to give us 4a. For the whole numbers, we've got negative 2, we've got positive 5. Negative 2 plus 5 is positive 3. So this is our answer. For subtracting the polynomials, it's going to be a little bit trickier because we're subtracting all the second terms. So let's start with the x squareds. I've got a negative x squared and I've got a negative 3x squared, so I can combine them. We should do negative x squared minus negative 3x squared. What's minus and negative the same as? Well, that's just plus. So this is like negative x squared plus 3x squared. And what's negative x squared plus 3 more x squareds? That's 2x squareds total. So our first term is 2x squared. Next up, we look for our x terms, but there's only one of them. It doesn't really have a neighbor on the other side. When you have one term, when there isn't a matching term in the other polynomial, put a 0 in place of the other one. This would be 0 minus negative x, because we treat the fact that there's no x's here like it's 0. Well, again, minus negative is the same as plus, so this is 0 plus x, which is just positive x. Lastly, we have the negative 5 and the negative 8, and negative 5 minus negative 8 is something that we can do because we can treat two negatives, minus a negative, as the same as being a positive. This is negative 5 plus 8. and negative 5 plus 8 is 3. There we go. If you did this section right, write down the letter A in this box. If you didn't do it right, go back and check to see if you can find your error. Next page, 7.2. I'm going to be using the double distributive property for this. Whenever you are multiplying polynomials, you can use the double distributive property. The idea is every term in the first polynomial should multiply every term in the second. So let's start by doing b times the first and b times the second. Well, b times b we write as b squared. B times 2 is 2b. Then we continue by doing it with the negative 3. We do negative 3 times b and negative 3 times 2. Negative 3 times b is negative 3b, and negative 3 times 2 is negative 6. From here, do we see any like terms that we can combine? Because I do. I see that positive 2b and negative 3b can be combined. What's 2b minus 3b? That's negative 1b. So I can just write that as negative b in the middle. That's our answer. We can do the same thing with problem number 2. Double distribute and then simplify. 3n times n is 3n squared. Think of it like 3 times n times another n. 3n times 1 is just 3n. So we can write that there. Negative 4 times n is negative 4n. And negative 4 times 1 is negative 4. Again, we can combine these n terms in the middle. 3 minus 4 is negative 1. So we get 3n squared minus n minus 4. For problem number 3, we do the same thing. It's the same process. Double distribute. So we're taking this 2 and we're going to multiply it to everything in the second term. It's just this time there are 3 of them. 2 times 3a squared is 6a squared. 2 times 3a is 6a. 2 times negative 5 is negative 10. Then we repeat the process. Negative a times 3a squared, well, that's 3 times a times negative a. There are 3 a's in play here. It's negative 3a cubed, or to the third power. Negative a times 3a is negative 3a squared, and negative a times negative 5 is positive 5a. Now we just need to look for terms we can combine. So first off, let's start with the highest. Is there anything that can be combined with negative 3a cubed? Not really. There's no other a cubes. So we write that as our first term. What about 6a squared? Can anything combine with that? Well, absolutely. There's a negative 3a squared. 6a squared minus 3a squared is 3a squared. Up around here, we've got positive 6a, and we have positive 5a. That's just 11a. And then, of course, we've got this minus 10 all by itself. Negative 3a cubed plus 3a squared plus 11a minus 10. All right. Next up, we do the same process for problem number 4. Double distribute. D times d squared is d cubed. D times negative 4d is negative 4d squared, because it's d times d. D times 1 is just d. Then we repeat the process with this 3. 3 times d squared is 3d squared. 3 times negative 4d is negative 12d. And 3 times 1 is 3. So let's combine like terms again. D cubed can't combine with anything, so we just write d cubed. But negative 4d squared and 3d squared can combine. Negative 4 plus 3 is negative 1. So it's like negative 1d squared, which we write as negative d squared. D combines with negative 12d. How many d's do we have? Well, 1 minus 12 is negative 11. And then we have a plus 3 at the end. If you got all 4 of these questions correct, give yourself a P. Let's flip the page. Over here, we are using special products. These formulas will help you greatly, but you'll have to memorize them if you want to use them. So, let's begin. Anytime you have the square of a binomial, here's how the pattern works. You are going to get, oops, sorry, didn't mean to do that there. The first term is going to be the first term squared. It's just a squared. The last term is the second term squared. So 3 squared, or 3 times 3, is 9. Your middle term is the toughest one to do. According to the pattern up here, it's 2 times a times b. So we have to do 2 times a times 3. Since 2 times a times 3 is 6, we have a 6x in the middle. And since this is a plus, this is a plus. Done. With number 2, we can use the similar pattern. The first term is the first term squared. So what's b squared? Well, it's b squared. The last term is the last number squared. And keep in mind I said the last number. This minus sign we can just treat as sort of chilling out there. We don't need to do any math with the minus sign if you know the pattern. 2 squared is 4. And it's going to be a plus. That's both according to the pattern and from doing 2 times 2. The middle term is 2 times a, in this case it's the letter b, that's confusing, times 2. 2 times b times 2 is 4b, and should it be a plus or a minus sign in front of it? Since this is a minus sign, this should be a minus sign. For 3 and 4, the patterns used are the sum and difference pattern. When you have a plus and a minus happening, the middle term is going to disappear. It's just a squared minus b squared. Our a in these is x. So what's a squared? It's x squared. Our b in this is 3. So what's 3 squared? 9. With the sum and difference pattern, you are always, always, always going to have a minus sign in between. So with number 4, it's the same thing. What is our first term squared? That's just t squared. What is our second term squared? 11 times 11 is 121. And we should put a minus sign in between because it's always a minus sign if you're using the sum and difference pattern. If you got all 4 of these answers, give yourself a letter P in this box here. Section 7.4 is our first factoring problem. Now, I wrote this down in the notes, but you should have made both of these equal 0. So the sub should tell you that these 2 problems should have an equal 0 after them. If something is in factored form, if it's a bunch of different factors being multiplied together, you can go ahead and solve right away. To solve a polynomial, we set each factor equal to 0. So see how our first factor is c minus 2? We set c minus 2 equal to 0 and solve. To solve that, we would add 2 to both sides, because that's what gets c by itself. c equals 2 is our first answer. Here, if it's c plus 1 that we're setting equal to 0, to get c by itself, we subtract 1 from both sides. That's going to give us c equals negative 1 as our answer. Done. We can do the same thing for number 2. Just set each piece equal to 0. So if 5p equals 0, what should p be? To figure that out, we divide both sides by 5, and get p equals 0 divided by 5 is 0. So p equals 0 is the answer. But we still have another factor, this p minus 2. To solve this, we set it equal to 0. We add 2 to both sides. P equals 2. Done. For problem number 3, the problem is not in factored form. You can tell because it's not grouped up in parentheses like this. So we need to first factor it. To factor, ask yourself, what can I take out from both of these terms? Well, both of them can be divided by 3, and both of them have an x in it, so we're going to pull out a 3x. 6x squared divided by 3x is 2x. 3x divided by 3x is 1, and this equals 0. Now it's in factored form, so just like the other questions, we can set each piece equal to 0. If 3x equals 0, how do we solve for x? We divide by 3 on both sides. X equals 0. If 2x plus 1 equals 0, this is going to be actually a two-step to solve. First, subtract 1, because reverse PEMDAS says we have to get rid of any addition and subtraction first. Then, we can divide both sides by 2, getting x equals negative 1/2. Done. For problem 4, we do the same thing. We check to see if there's anything we can factor out from these terms. And there is. Notice how both of these can be divided by 4, and both of them have at least 3 y's inside of them. We can factor out 4y cubed. What are we left with when we take out the 4 and 3 of the 4 y's? Just one of the y's left over. What's negative 20y cubed divided by 4y cubed? Well, the y cubes cancel, so what's negative 20 divided by 4? Negative 5. We then set each piece equal to 0. So if 4y cubed equals 0, we have to figure out what y is. And if y minus 5 equals 0, we have to figure out what y is. For this one, let's start by dividing 4. We get y cubed equals 0. And this is just asking, what number times itself 3 times makes 0? Well, 0 times 0 times 0 makes 0. 0. For this one, we add 5 to both sides, getting y equals 5. Done. If you got all of these correct, give yourself the letter L. Let's flip the page. Seven 7.5 is all about factoring using our combinator. So, let's take a look at problem 1. To set up a combinator, what you're going to do is, you're going to make a big X, and you're going to see what multiplies to make the last term. Since the last term is 18, we're seeing what multiplies to make 18, and what adds to make your middle term. So we're seeing what adds to make 11. When you get quick enough with these, you will no longer need to use the combinator. So what multiplies to make 18 and adds to make 11? 9 and 2. With these type of problems, when your a is 1, we can then just take this and write our answer. Our answer is x plus 9 times x plus 2. Done. Number 2, we are trying to solve. So for a solving problem, we have to make one side equal to 0 before we do anything. How do we turn a negative 2 into a 0? Well, by adding 2 to both sides. This is going to give us r squared minus 3r plus 2 equals 0. Once again, since there's no a value, we can go to a combinator. What multiplies to make 2 and adds to make negative 3? This one's a bit tougher, but we should have gotten 3 and negative 1. Whoops, sorry. I apologize, y'all. That should actually be negative 2, negative 1. See, even Mr. Strayer gets it mixed up. Negative 2 times negative 1 is 2. Negative 2 plus negative 1 is negative 3. So this is r minus 2 times r minus 1 equals 0. And on the last page, we talked about how to solve these. Set each piece equal to 0. If r minus 2 equals 0, we can add 2 to both sides to get r equals 2. If r minus 1 equals 0, we can add 1 to both sides to get r equals 1. Done. Again, on this problem down here for 3, we need to first get one side equal to 0. So we subtract 30 from both sides to make that happen. X squared minus x minus 30 equals 0. All we need to do now is factor it. So, since there's no a value, we can set up a combinator. We're looking for two numbers that multiply to make negative 30 and add to make negative 1, because that negative x is secretly a negative 1x. The two numbers that make this happen are actually going to be negative 6 and positive 5. Negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. So we write it out as x minus 6, x plus 5 equals 0. And from here, we just solve each side. X minus 6 equals 0. X plus 5 equals 0. Therefore, we just have to add 6 to both sides here, getting x equals 6. On this one, we have to subtract 5 from both sides, getting x equals negative 5, because we set each piece equal to 0 to solve. If you got all of this correct, please give yourself an A. 7.6, factoring when this should say A does not equal 1. This is where we might have to use the GCF method. This is also where we might use the AC method. So, for problem number 1, the first thing we should look for is there a greatest common factor? Always, always, always check for a greatest common factor. In this case, all three terms can be divided by 5. So we pull out the 5 and see what's left over when we divide each term by 5. Well, 5s squared divided by 5 is just s squared. 55s divided by 5 is 11s. And 50 divided by 5 is 10. From here, we can factor the inside. Notice how there's no a value anymore, so we can jump to a combinator. What multiplies to make 10 and adds to make 11? It's going to be 10 and 1. So we rewrite our factored form here as s plus 10, s plus 1. Done. Number 2, let's see what we can factor out. So we notice that all three terms can be divided by 3. So we factor out a 3, leaving us with q squared plus 10q plus 9. Now, we've learned some pattern recognition. If the first term is a perfect square and the last term is a perfect square, we might be dealing with a perfect square trinomial. Let's see if it's a perfect square trinomial, because it'll make it a lot easier if it is. To do perfect square trinomial, this is 7.6 stuff. Remember, it's a trinomial, so you're going to get something squared. What's the square root of q squared? Q. What's the square root of 9? 3. The last thing you need to check is the middle term 2 times q times 3? Uh-oh, 2 times q times 3 is 6q, not 10q, so we can't actually use this shortcut. Again, ideally you'd be doing all of this in your head. If you can't use the shortcut, but there's no a value, we can go straight to a combinator. So we're trying to figure out what multiplies to make 9 and adds to make 10. It turns out that this is 9 times 1, or 9 plus 1. So we get 3q plus 9, q plus 1. Done. For problem 3, we notice that there's no greatest common factor. But, there is an a value. So we need to use the AC method. The first step of the AC method is to multiply a times c and put it in the top of your combinator. So what's 9 times 2? 18. Okay, we're looking for two numbers that multiply to make 18 and add to make 9. That is 6 and 3, or 3 and 6. I'm going to write out my original trinomial, replacing the 9w with a 6w and a 3w. So 9w squared is just like the original. I'm going to write the 3w first, then I'm going to write the 6w, and then in the original, it's plus 2. From here, we can actually use factoring by grouping. So what can we pull out of our first group? Both of them can be divided by 3w. What's left over when I do that is 3w plus 1. What can I pull out of my second group? Both can be divided by 2. So we're left with 3w, when we divide 6w by 2, plus 1. If the parentheses match, we know we did our grouping correctly. So we can just write out our final answer. The factors you're able to take out become your first factor. The factors in parentheses are your second. This is our answer. We can do the same thing with problem number 4. Notice how there's nothing we can take out from this one. There's no GCF. So we have to use the AC method. 12 times negative 2 is going to give us negative 24. So let's find two numbers that multiply to make negative 24 and add to make 5. These two numbers are 8 and negative 3. So when we go back to our original trinomial, we can split our middle term, 12a squared. Instead of 5a, we can rewrite this as negative 3a plus 8a. Again, the order doesn't matter because you can always switch it around if it doesn't work. Minus 2. We now group our first two and group our last two. So what can we take out from 12a squared minus 3a? Both of those can be divided by 3a. 12a squared divided by 3a is 4a, and negative 3a divided by 3a is negative 1. What can I take out from 8a and negative 2? Both can be divided by 2. So 8a divided by 2 is 4a, and negative 2 divided by 2 is negative 1. Again, since our parentheses match, we know we did it correctly. All we need to do now is have what we took out be our first factor, and have what's left over in parentheses be our second. Our answer is 3a plus 2 times 4a minus 1. Done. If you did 7.6 correctly, write the letter U in the circle. Seven 7.7 is another use of special products, just like 7.3. For these special products, we're basically going in reverse, but you're going to use these rules to help you. Again, you should memorize these rules if you intend to use them, especially the difference of two squares pattern. So, to factor a binomial, we should first check, are both numbers perfect squares? Yes, t is a perfect square, 81 is a perfect square. Is there a minus sign between them? Yes. So the difference of squares pattern says that we can go straight to two sets of parentheses, one that has a plus and one that has a minus. The first term in both binomials is the square root of t squared. It's just t. The second term is the square root of 81. Whoops, I wrote this as a plus, not as a minus. I'm sorry, y'all. I'm going to just scratch this one out and rewrite it. We should get a plus in one of them and a minus in the other. Like I said out loud, the first term is t, the square root of 81 is 9. So this is our answer, t plus 9, t minus 9. In problem 2, we can recognize the same thing. Are both of these perfect squares? Yes, 4g squared and 25g are perfect squares. Is there a minus sign between them? Yes. So we can use the difference of squares pattern. Put a plus sign in one of your parentheses, a minus sign in the other. Now let's figure out what the square root of both of these are. To do the square root of 4g squared, first do the square root of 4. Square root of 4 is 2. Then do the square root of g squared. The square root of g squared is g. So our first term in both binomials is 2g. Lastly, the square root of 25 is 5. So we can write that and have our answer. For the perfect square trinomials, it's a little bit trickier. First off, both patterns will result in your answer being something in parentheses squared, if it works. Here's what we're going to do. First things first, find the square root of your first term. The square root of x squared is just x, so that's going to go first. Then find the square root of your last term. The square root of 64 is 8, so that's going to go last. Before we finish this off by putting the sign in, we should check to make sure this is a perfect square trinomial. To do that, we should do 2 times this x that we found times this 8 that we found, and see if it makes our middle term. 2 times x times 8 does equal 16. So the sign in front of the 16x will determine the sign in parentheses. It's a plus here, so it's a plus here. For number 4, we can set up the same way. It's going to be something squared. To figure it out, let's do the square root of the first. The square root of r squared is just r. Then we should do the square root of 169. When in doubt, use your calculator, but the square root of 169 is 13. So now we just need to check. If 2 times r times 13 equals 26r, we ignore the sign for now. We're just looking to see if the numbers match. And yeah, 2 times r times 13 is 26r. So to determine what sign goes in the parentheses, it's the same sign in front of 26r, a minus sign. If you got all of these correct, give yourself a big S. For 7.8, we're putting it all together. We're factoring by grouping, and we're seeing if we can factor something completely. Let's start with factoring by grouping with number 1. We know we have to use factoring by grouping because there are 4 terms. Anytime there are 4 terms, factoring by grouping is the only way we know how to do it. There comes a bit of a problem with this one, though. Sure, I could take something out of this first group, but can I take something out of this second group? No, there's nothing in common between b and negative 4. One solution is just to take out a positive 1, but sometimes it doesn't quite work out. So let's see if we can rearrange our grouping problem. I need to pair up something with b cubed that can be factored and something with negative 4 that can be factored. Well, what if I just switch the negative 4b squared and the b? If I pair up b cubed and b, I can take out a b. If I pair up the negative 4b squared and the negative 4, I can take out a negative 4. So this is a much better grouping. Like I said, b cubed and b both can be divided by b. leaving us with b squared plus 1. Remember, anytime you take out something entirely, leave a 1 in its place. Similarly, with negative 4b squared and negative 4, I can pull out a negative 4. Since the first term is negative, you should always try to pull out a negative. This leaves us with just b squared plus 1. Now we can put together what we took out. So b minus 4 is one of our factors, and whatever's in parentheses is our other factor. Done. We want to be careful, because we might say, Mr. Strager, b squared is a perfect square, and 1 is a perfect square. But we want to keep in mind that the difference of squares pattern only works if there's a difference of squares, not a sum. This is a plus sign. Over here with number 2, we can see if we can group this. So, we group these two. What can we pull out from the first group? The first group, we can take out 2a squared. Left over, we would have 6a and a plus 1. If you ever take out something entirely, leave it as a 1. In this next group, you see how we have a negative 3 and a negative 5? We can factor out a negative 5 here, leaving us with 6a plus 1. Finally, we can just put together what's on the outside as our first factor, and what's on the inside as our second factor. Done. We check to see if we can factor these further, but none of them match any of the patterns that we've seen so far. So there we go. For number 3, we should first always check to see if there's a greatest common factor we can pull out of everything. And there is. You see how all these can be divided by 2? Let's pull 2 out of all of them. Left over, 20p squared divided by 2 is 10p squared. 22p divided by 2 is 11p. Negative 12 divided by 2 is negative 6. Uh-oh. Inside of the parentheses, we still have an a value, and it can't be factored out. This 2 is just going to be chilling forever, but this 10 means that we have to use the AC method. So let's ask ourselves, what multiplies to make... Sorry, I apologize, I skipped ahead. Let's multiply our a times c. 10 times negative 6 is negative 60, and our middle term is 11. So what multiplies to make negative 60 and adds to make 11? It turns out that 15 times negative 4 is 60. 15 minus 4 is 11. So for the AC method to work, first off, this 2 is just going to be chilling out here until the end of time. But inside of our parentheses, we rewrite the problem with our middle term being replaced by 15p, I should say, and negative 4p. And we have the minus 6 at the end. Next up, we see that there are 4 terms, so let's group them. I'm using brackets because we've already used parentheses. You can use double parentheses if you want. So that 2 is just going to be chilling. What can I take out from the first group? Well, 10p squared and 15p both can be divided by 5 and both have a p in it. So let's pull out a 5p. What's left over would be 2p plus 3. From negative 4p and negative 6, both of these can be divided by negative 2. And in parentheses, what will be left over is 2p plus 3. We know we did it right because the parentheses match. And again, I'm going to use brackets to distinguish them. You can use parentheses if you want. All we need to do now is group together the stuff we took out as well as group together our parentheses. So 2 is still chilling there on the outside. 5p minus 2 becomes one of our factors. And 2p plus 3 becomes our last factor. Done. For number 4, let's see what we can factor out. Notice that 12, negative 20, and negative 48 can all be divided by 4. So we pull out the 4 and put everything else in parentheses. So 12x squared divided by 4 is 3x squared. Negative 20x divided by 4 is negative 5x. And negative 48 divided by 4 is negative 12. Again, we've got a case where we'll need to use the AC method. So let's do A times C, so 3 times negative 12, and put it in the top of our combinator. 3 times negative 12 is negative 36. Negative 5 is what we're adding to make. So what multiplies to make negative 36 and adds to make negative 5? Negative 9 and positive 4. So what we'd be left with is we rewrite this with our middle term changing into negative 9x and 4x. So we've still got our 4 chilling on the outside, as it always will. 3x squared minus 9x plus 4x minus 12. Whoops, that's a plus 12. I meant to say minus 12. You guys can tell it's a big minus, right? Now we can do our favorite thing and group together our terms. So what can we take out from the first group? Well, 3x squared and negative 9x can both be divided by 3x. And what would be left over in our parentheses, 3x squared divided by 3x is just x. Negative 9x divided by 3x is negative 3. What can we take out from our second group? Well, 4x and negative 12 can both be divided by 4, so we take out a plus 4. And in brackets, or parentheses, whichever one you choose to use, 4x divided by 4 is x, negative 12 divided by 4 is negative 3. To finalize our answer, these two become factors. So 3x plus 4 is a factor. And what's in parentheses becomes a factor, x minus 3. If you finished this one off, give yourself an E. What that means is when we put all of our stamps together, you get applause. So give yourselves a round of applause for completing this packet. Thank you so much, everybody. If you have any questions, feel free to email me or talk to me or another ID teacher during ID on Monday or Tuesday. Take care.